Okay. This is the Z stopper. Good. And now we're gonna make sure that both of these, alright, that's 8 and then one more centimeters wise, and this one is 8 and then 4 more. Okay, so now the right and left stepper motors are even, and the hot plate's about centered. The Z stopper is at the top, and just for fun, we'll put the print head in the center. I'm going to plug it in now. Home. Quick settings, which is down. Press right to enter. Down to home all. Press right again. Holy crap, something's still wrong. Something's very wrong. They're all uneven, everything's really messed up right now. Let me unplug it then. I believe we have an issue with the left hand not wanting to turn. Why is that happening? Alright, is it plugged in all the way? Yes, that's Z motor 1. It's fine. Well, shoot, what else could it be wrong? It's really hard to turn it. The left vertical motor, or Z motor, doesn't... It gets jammed up. That's the issue. It's getting jammed up. And, we don't know what it is yet. We don't know the cause. So this pull on the vertical axis of the Z was somehow jamming in the container that holds the X motor. This vertical shaft was somehow binding on this pull. Now, I believe the pull's straight. Maybe the shaft is not straight. It almost seems like the whole like the whole thing is like this. Wonder if I could measure the orientation. I don't know how I do that. Well, let's see. The first thing, I want to make sure this is even. As far as the heights of the Z. Wow, the heights look apparently very even. Uh, Alright, I think it's time for duct tape. I don't actually know what the... How long did you guys think it'd be before I start using duct tape? Um, okay. No, I don't think that's gonna be okay either. This can't have that much give at all. I got it. I got it. I got it. Okay. That's not gonna work what I just did, so let me just reverse. Abort that particular approach. Um... Alright, so what I did here is I removed the set screws. Um, oh, look at that. That one's not screwed in. Alright, so there's 2 set screws on the top and 2 on the bottom. I removed all 4, and then I raised this coupling way up. I could fit my finger under it. So that the worm drive shaft can still be seated in the coupling, but then the top of the shaft can actually rest right, like, to where it's in this hole, providing some kind of stability for it. It's not even touching really, just kind of resting there. We completely removed this left shaft, which goes right next to it, because it's bow-legged. If my calculations are correct, it should drop right into here if it were in fact vertical, and it doesn't. Meaning it's off. Huh. I wonder what would happen if we left it like that and then just create a new hole on this shelf, like supporting wherever it lands. Because however it is now, that's going to be perfectly straight with with this orientation, the orientation of this thing. Let's say it's cockeyed a little bit. At least now it'll be straight, and not being interfered with. The problem was that this white shaft was, or this white, yeah, hollow shaft was cockeyed with this rod. And so the rod was causing the shaft to create a lot of friction. And any difference in friction between the 2 motors, if they're being fed the same voltage, will cause one motor to move faster than the other. And the minute one motor moves faster for any reason, they lose their relative heights, so that one starts to get really high, and then the problem gets even worse because that adds additional friction, because now the whole system is becoming very cockeyed, and so that creates a ton of friction then. Alright, this is exactly 5.5 centimeters. This is not exactly 5.5 centimeters. What the crap, man? Six and exactly 6. Good. This should be 10 millimeters. Exactly 6.5. Exactly 6.5. Exactly 7. Exactly 7. Exactly 7.5. Exactly 7.5. Exactly 8. Exactly 8. So they're really moving in perfect synchrony now. 8.5. 8.5. Perfect. So, I'm manually adjusting the positions using the LCD display. I went to, alright, from the system screen you hit menu, you scroll down to position, hit the right arrow. It says back, home all, home X, home Y. I keep scrolling down till I hit Z position fast, or Z POS dot space fast. Hit right, and then it says Z 35.00 millimeter. Min end stop off, max end stop NA. If you press up or down, it moves it. And you can just keep taking measurements. I'm at 9.5. 9.5. I mean, it's very reliable right now. You know, incidentally, it's not wobbly at all. It's just so funny that we have literally this bottom thingamabob just sitting. It's resting and it's not lined up with the hole. You'll see here what I mean. Maybe we can get our knife down in there. Need a different angle. What the heck, man? It's like everything's shadow here. I mean, the knife shouldn't be able to go in the hole. Not with the pole lined up with it. So the bottom line is there's some major fundamental issues. Maybe it's just the whole frame is askew. Maybe there was bending and shipping. I don't know. But this fix has worked. Everything, there's no friction now on the motor, which was what caused the changes in speed to begin with. I'm just wondering, why when I study this, it's like, yeah, I can see. Oh my gosh. Check this out, guys. Look at this. Let me get my X-Acto knife. So, I was just studying the fact that on this bottom platform, the hole is about 1 millimeter further that way than this shaft lands. The shadowing's so bad here because everything's so shiny. And it should land right in it if everything were lined up. And I was thinking, so that means that at the point where it contacts this vertical shaft, it's bringing our pole uh, it's bringing our pole this way. This way. That's why the pole's landing this way of the hole, which is that way. The hole's that way, or let's just say left and right. I need to stop pointing. So this pole lands to the right or forward in the Y direction from where the hole is in the base. Now we force the pole to go um, to my left to cram it into that hole. But that puts a lot of tension onto here, this white box, because now we got a bend in the pole, which we're forcing in by pushing it to my left in order to cram it down that hole. And as this box slides down, it hits that bend, and it creates a lot of friction because it can't cross that bend. It's very tall, and when there's a bend in this metal rod, it can't follow that. So it gets jammed up like right here, and it would go and the motor would be too weak to force it down. And so the other motor, which was working as intended, would just go flying down, and this one wouldn't be moving at all. And this motherboard doesn't have feedback showing, hey, this motor height is behind, slow down the other motor and add more power to this motor. It doesn't have any feedback loop. So there's no intelligent sensory that, hey, we're running up on some friction on the left side, and so we need to increase the power to pound through that and then slow down the other one in order to keep them level at all times. It wasn't doing that. It has no intelligence. So if for any reason there's a mechanical interference with one of the Z motors but not the other, the one with no interference is going to go flying at 2 or 3 times the speed, and then that's going to cause your whole system to be screwed up because now your hot plate can never be level. You're just all over the place. One side of the machine's lifting, an inch higher than the other. It's just a total cluster screw. And so anyways, what I was noticing is, in trying to break down, like, well, what's causing it beyond that, I noticed, check this out, the distance from here to here and from here to here. Look at this. This top part is like maybe a toothpick's width. And as you come down to here, this bottom gap in the plastic is like 2.5 toothpicks wide. I don't know if you can see it, but this is a lot wider on the bottom than this. Boom. Boom. It gets really narrow at the top, which tells me that it's almost like this plastic is like cracked, or I don't know. I don't know why that thing would be opened up like that, but that's like a big red flag of a manufacturing default or manufacturing problem. Also, I saw a tiny little set screw fall out of this printer yesterday, and it makes me wonder, was it from that? I don't know. But basically, what? What is our conclusion here, folks? What is the fix? I mean, we know it's a mechanical issue, and that's kind of nice. In fact, along the same line, I don't even think this matters, but I'll put the motors back where they were. We were just swapping the Z2 and Z1 motor to different plugs on the motherboard because we thought that maybe one of the motherboard output drivers was giving the wrong current to one of them, and that caused the imbalance. But no, it's something mechanical involving friction And that's all because of this pole being all weird. So we put that back how it is. So yeah, we've got this not lining up, and it's impossible to say. I mean, you could make the argument that I don't even know what argument you would make. I mean, clearly something's wrong here. It could be just a faulty construction of this whole white plastic piece, because it's just got this obvious gap here that's not even, and the pole wants to run slightly like that toward the back from the bottom because of this unit. And I don't know what to say. I guess my best bet is this. Since it's now working perfectly without this thing shoved back, just landing wherever it lands, just leaving it be, I would say the best solution from there would be to hot glue it into place and just let it be where it wanted to be, wherever there's least mechanical repercussions. And we can do the same on the top. And just assume that when that cures, that's just going to keep this pole generally where it is, and everybody will be happy. Also, it's kind of nice because it's flexible. As this machine kind of rattles, the hot glue joint is basically rubber, and so it will provide a little bit of vibration dampening. And really, the whole point, to my knowledge, of these vertical shafts is just stability. This one's stability, and then this one's propulsion. So the threaded shaft is what gives it the up and down actuation, and then the clear shaft just gives it a solid directional guide. The conclusion is not that it's ruined. The conclusion is that we made our first mod, and everybody has said unanimously that this particular printer does not come out of the box as a piece of flawless engineering and perfection. That you can expect little quirks and little tweaks to be necessary to make the printer operate at its highest potential. So these types of tests I think are really great, just to verify everything and clean up these little problems. This is just my first problem. You're kind of signing up for that when you buy a really cheap printer like this. Alright, I just want to keep going with the position tests. That glue has cured, I believe. Yeah, it's all dry. So back to position. We're just going to keep running Z tests. I mean, Z was where all of our problems were. Z pause fast, and we're just going to keep moving it on up, and and measuring, making sure that the entire stroke length from top to bottom is uniform. So there's 10, 10. Okay, there is almost 13. Almost 13, but not quite. Okay, that's pretty accurate. 13 and a half. 13 and a half. One less than 14. A little less than 14. The precision's getting a little off. 14 and a half. 14 and a half. I mean, it's pretty close. A little less than 15. Tiny bit less than 15. 8.5. 8.5. It's perfect. It's absolutely perfect. So, I'm gonna home everything out. I'm finally. It's tough because you put together a 3D printer for the first time, you don't know what you're doing, and then you run into a major manufacturing flaw right off the bat. Boom. That's what you're greeted with. Just a complete malfunction.